for this. Well, let me say though, the real goal of today is to kind of work towards graphing rational functions. But let me just do kind of a couple examples of solving rational equations. So this is an example of solving rational equations. So something like this. X squared plus 6x over x plus 3 minus 4 is equal to -9 over x plus 3. Okay, so this is an equation involving rational functions. So here's a rational function. And a rational function is basically if you have a polynomial as your numerator and a polynomial as your denominator of a fraction. And I always thought that, this is until very recently, I always thought that, I thought this is kind of a weird name for it. Like, why is it called rational? Are other functions irrational or something? But no, it's not, it doesn't have anything to do with reason. It has to do with the fact that it's a ratio. The word ratio is kind of built in there. So it's a ratio of two functions. That's a rational function. The way I like to handle these, there's actually lots of ways of solving this equation. And if you have your own way, go for it. But the way I like to solve these is to get rid of the fractions as soon as possible. It's not that I don't like fractions, I do like fractions. But for these problems, I just want to kill the fraction as fast as possible because that makes it, in my mind, easier to solve. So how do you do that? Well, let me move this over. Move this up here. There we go. That kind of works. The way to do this is to multiply both sides by every single denominator you see. Now, there's really only one denominator in this problem, but in a bit we'll do an example where there's two denominators. But anyway, so we'll look at every denominator and then we're going to multiply that by that. And again, in this case, it's just the x plus 3. So this is what's going to kill those denominators. I call this clearing denominators. There we go. Okay, so what happens here? Well, this x plus 3, if you think of this as just a big blob, it's actually going to distribute in here. It's going to distribute in here. And it's the same thing for this one. And if you think about this as being over 1, think about this as being over 1, you can see that the x plus 3 part is only going to go to the top of my fraction. So it's going to look like this. I have x squared plus 6x, and I'm going to get an x plus 3. Right there. Now this -4 also gets an x plus 3. And that's going to be equal to, and I'm kind of, might be able to put this in here, so it's going to be equal to -9, that gets an x plus 3. Over x plus 3. So the thing to notice there is the x plus 3 goes to every single term. So this was a term down x plus 3, this was a term down x plus 3, this was a term down x plus 3. Goes to every single term, but only on top of any fraction. Okay, Now this looks a little bit more complicated than the original problem, but you'll notice that we chose what we multiplied by exactly so that these would cancel. All your fractions should cancel at this step because you've multiplied by every denominator. All denominators should cancel. And we are left with, we're left with an x squared plus 6x. This we can distribute, get minus 4x minus 12 is equal to negative 9. Now we're not done with the problem yet, but we're actually done with the new stuff because this is just a quadratic equation. We know how to solve this. I'll go ahead and do that real fast, but basically the new stuff is over except for one tiny caveat at the end. So I will, I always have trouble scrolling. Let me try it today. Okay, I'll scroll down here. I think I can finish this problem up pretty fast. So this is going to be x squared minus 2x. And if I just add this 9 over, it's going to be a minus 3 equals 0. Well, this factors, of course, is x. Sorry, this is plus 2x. Sorry, kind of gets this up. Still factors. This is going to be x plus 3, x minus 1 is 0. So to get the solutions of x equals negative 3 and x equals 1. Whew. So we have the solutions. There's a problem though. Does anybody see it? There's an issue with my solutions. Does anybody see what I'm getting at? What's the issue here? Matt.
Your denominator can't be 0, right?
Right. So why is that a problem?
Because if it's 0, it's irrational. Like you can't even progress in the problem. So it can't be negative 3.
Right, yes. This is not a real solution. I mean, we did everything right. We got that as a solution. This is called an extraneous solution. So the right thing to do in an algebra problem with an extraneous solution is to derive that solution and then cross it out at the end. And again, the reason this doesn't work is because if you plug it back into the original, let me scroll back up here. Well, actually any of these, but in particular, if you plug it into the original, you'd get division by 0 here. Which is a problem, obviously. So that's something to watch out for with these rational equations. It doesn't happen very often. I find that most rational equations, it's unlikely that your solution happens to also be your denominator, but something to watch out for. Okay. Let me actually stop.